Hi everyone. This presentation will prove the sunlight coverage described in 1st Enoch, chapter 72, throughout a year is verified by observed navigational data. The purpose of this presentation addresses comparing the hours of sunlight for the 12 months described in 1st Enoch, chapter 72, with the observed navigational data of the sun from the United States Naval Observatory. This presentation does not address resolving Yahuwah's 364-day-year calendar with the world's 365/366-day-year calendar. First Enoch chapter 72 describes Yahuwah's perfect and complete 364-day-year calendar. In chapter 72 of First Enoch, the angel Uriel showed Enoch the courses and the laws of the luminaries of the heaven. Yahuwah's calendar is solely based on the sun's duration of sunlight as the sun travels north and south during 1 year. The moon and stars are never mentioned. There are 12 months, each consisting of 30 days, which equals 360 days. Months 3, 6, 9, and 12 have a 31st day, which is a season transition day. These 4 days result in the calendar being 364 days. Day 31 of month 3 is the transition day from spring to summer, summer solstice, and day 3 of the week. Day 31 of month 6 is the transition day from summer to fall, fall equinox, and day 3 of the week. Day 31 of month 9 is the transition day from fall to winter, winter solstice, and day 3 of the week. Day 31 of month 12 is the transition day from winter to spring, spring equinox, day 3 of the week, and the 364th day of the year. The first day of months 1, 4, 7, and 10 begin each season of the year. Day 1 of month 1 is the head of the year, first day of spring, and day 4 of the week. Day 1 of month 4 is the first day of summer and day 4 of the week. Day 1 of month 7 is the first day of fall and day 4 of the week. Day 1 of month 10 is the first day of winter and day 4 of the week. The number of days between each of the 4 season transition days is 91 days. 91 days times 4 equals 364 days. Based on the duration of sunlight from months 1 through 12 in 1st Enoch chapter 72, Enoch viewed the sun's movements from a specific latitude location north of the equator. After performing some iterations, plus 50 degrees north latitude is the location where the actual hours of sunlight observed best match 1st Enoch chapter 72. Plus 35.22 degrees longitude was used as this is the timeline for Jerusalem, Israel. The Gregorian calendar dates for season transition days in 2025 and 2026 are 2025 spring equinox, where the sun is physically above the equator, March 20th, which is day 5 of the week. 2025 summer solstice, where the sun is physically above plus 23.4 latitude, June 21st, day 7 of the week. 2025 fall equinox, where the sun is physically above the equator, September 22nd, day 2 of the week. 2025 winter solstice, where the sun is physically above minus 23.4 latitude, December 21st, day 1 of the week. 2026 spring equinox, where the sun is physically above the equator, March 20th, day 6 of the week. Unlike Yahuwah's perfect and complete 364-day calendar, we notice the season transition days are on different days of the week, and the number of days between the season transition dates are 93, 93, 90, and 89, which adds up to 365 days. Alignment of 1st Enoch calendar with the Gregorian calendar. 1st Enoch chapter 72 season transition dates are first aligned with the Gregorian calendar season transition dates. In 2025, the 31st day of month 12 is March 20th, 2025, spring equinox. The 31st day of month 3 is June 21st, 2025, summer solstice. The 31st day of month 6 is September 22nd, 2025, fall equinox. The 31st day of month 9 is December 21st, 2025, winter solstice. The 31st day of month 12 in 2026 is March 20th, spring equinox. The alignment of the other 8 months are as follows. Month 1, April 20th, 2025. Month 2, May 20th, 2025. Month 4, July 21st, 2025. Month 5, August 21st, 2025. Month 7, October 22nd, 2025. Month 8, November 21st, 2025. Month 10, January 20th, 2026. Month 11, February 19th, 2026. Now we will go through the process of obtaining observed sunlight data from the United States Naval Observatory. Anyone can follow this process to verify all the navigational data of the Sun for all the dates shown in this presentation. Step 1. Go to the United States Naval Observatory Astronomical Applications Department Data Services website. We see the website there. The Data Services page is shown on the right, listing various categories of data services. At the bottom of the page is the link to obtain altitude and azimuth data of the Sun or Moon during one day. Step 2. Select altitude and azimuth of the Sun or Moon during one day. Step 3. The altitude and azimuth of the Sun or Moon during one day page appears and is ready for specific input data. Items to be specifically inputted are Sun or Moon, date in month, day, year format, time interval between 1 minute to 120 minutes, latitude and longitude location, location label, and time zone east or west of Greenwich. Step 4. To obtain the observed sunlight data for March 20th, 2025, the data is entered as shown below. To obtain observed sunlight data for all other months, the date is changed. For months other than the equinoxes, the time interval is changed to 1 minute. Select Sun, select March 20, 2025, select 60-minute time interval, select plus 50 latitude and plus 35.22 longitude location. Location label is Ukraine, which is plus 50 latitude with the same timeline as Jerusalem, plus 35.22 longitude. Select time zone is 2.25 hours east of Greenwich. Step 5, select Get Data. Step 6, sunlight data for March 20, 2025 is obtained at plus 50 degrees latitude and plus 35.22 longitude. March 2025 is the spring equinox when the Sun is physically above the equator. Sunlight data shows 12 hours and 0 minutes of sunlight. Based on the altitude and azimuth angles of the Sun, the trajectory of the Sun can be shown throughout the day. This same 6-step process is followed for all Gregorian calendar dates in this presentation. The right side of this table provides summary data of the actual hours of sunlight observed in the day on the Earth for the Gregorian calendar date shown, which were obtained using the 6-step process as previously mentioned from the United States Naval Observatory altitude and azimuth of the Sun or Moon during one day. The hours of daylight ranges from 12 hours in the spring equinox, increasing to 16 hours on the summer solstice, decreasing to 12 hours on the fall equinox, decreasing to 8 hours on the winter solstice, and increasing to 12 hours on the spring equinox. On the left side of the table is the parts of day and parts of night described in chapter 72 of 1st Enoch. These parts of day and parts of night are always described on the last day of a month within a portal/gate. For instance, month 12 on the top row, 1st Enoch, chapter 72, 31 to 32 states, and on that day the sun rises from that portal and sets in the west, and returns to the east, and rises in the third portal or gate for 1 and 30 mornings, and sets in the west of the heaven. On that day the night decreases and amounts 9 parts and day to 9 parts, and the night is equal to the day, and the year is exactly to its days 364. On the 31st day of month 12, the sun is in the most northern location in portal/gate 3, which is directly above the equator because the night is equal to the day. 1st Enoch chapter 72 defines one day and one night being 24 hours consisting of 18 parts. Therefore, 1 part equals 1 hour and 20 minutes. Now, as we look at the first row, month 12, we see the sun is in its last day of portal/gate 3 with 9 parts day, 9 parts night, which equals 12 hours of day and 12 hours of night. We see on that same row the actual hours of sunlight observed on March 20, 2025. The spring equinox is exactly the same as described in 1st Enoch, 12 hours of day and 12 hours of night. Going across the table of each row from months 1 through 12, we see the actual hours of sunlight observed are the same as described in 1 Enoch chapter 72. This table shows sunrise and sunset times, altitude angles, and azimuth angles, which verifies the hours of day and night agree with the parts or hours of day and night described in 1 Enoch chapter 72. This table shows actual hours of sunlight observed for each date/month from sunrise to sunset at every 15 degrees of azimuth, which is at each solar hour increment during daylight. March 20, 2025 is the spring equinox, is month 12 of 1st Enoch, and has 12 hours of sunlight. April 20, 2025 is month 1 of 1st Enoch and has 13 hours and 20 minutes of sunlight. May 20, 2025 is month 2 of 1st Enoch and has 14 hours and 40 minutes of sunlight. June 21st, 2025 is the summer solstice, is month 3 of 1st Enoch and has 16 hours of sunlight. July 21, 2025 is month 4 of 1st Enoch and has 14 hours and 40 minutes of sunlight. August 21, 2025 is month 5 of 1st Enoch and has 13 hours and 20 minutes of sunlight. Solar high noon, or 180 degrees azimuth, is highlighted in various colors to show the sun's altitude angle. Knowing the sun's altitude angle at solar high noon, the sun's latitude location can be determined, which will be addressed later in this presentation. Using the detailed data in this table, the sun's trajectory across the horizon can be shown for each month. This will be presented soon. Again, this table shows actual hours of sunlight observed for each date/month from sunrise to sunset at every 15 degrees of azimuth, which is at each solar hour increment during daylight. September 22, 2025, the fall equinox, is month 6 of 1st Enoch and has 12 hours of sunlight. October 22, 2025 is month 7 of 1st Enoch and has 10 hours and 40 minutes of sunlight. November 21, 2025 is month 8 of 1st Enoch and has 9 hours and 20 minutes of sunlight. December 21, 2025 is the winter solstice, is month 9 of 1st Enoch and has 8 hours of sunlight. January 20, 2026 is month 10 of 1st Enoch and has 9 hours and 20 minutes of sunlight. February 19, 2026 is month 11 of 1st Enoch and has 10 hours and 40 minutes of sunlight. March 20, 2026 is the spring equinox and is month 12 of 1st Enoch and has 12 hours of sunlight. Solar high noon, or 180 degrees azimuth, is highlighted in various colors to show the sun's altitude angle. Again, knowing the sun's altitude angle at solar high noon, the sun's latitude location can be determined, which will be addressed later in the presentation. Using the detailed data in this table, the sun's trajectory across the horizon can be shown for each month, which will be presented next. Sun's trajectory, March 20, 2025, spring equinox, 1st Enoch, month 12, total sunlight time, 12 hours and 0 minutes. Sun's trajectory, April 20, 2025, 1st Enoch, month 1, total sunlight time, 13 hours and 20 minutes. Sun's trajectory, May 20, 2025, 1st Enoch, month 2, total sunlight time, 14 hours and 40 minutes. Sun's trajectory, June 21, 2025, summer solstice, 1st Enoch, month 3, total sunlight time, 16 hours and 0 minutes. Sun's trajectory, July 21, 2025, 1st Enoch, month 4, total sunlight, 14 hours and 40 minutes. Sun's trajectory, August 21, 2025, 1st Enoch, month 5, total sunlight time, 13 hours and 20 minutes. Sun's trajectory, September 22, 2025, fall equinox, 1st Enoch, month 6, total sun time, 12 hours and 0 minutes. Sun's trajectory, October 22, 2025, 1st Enoch, month 7, total sunlight time, 10 hours and 40 minutes. Sun's trajectory, November 21, 2025, 1st Enoch, month 8, total sunlight time, 9 hours and 20 minutes. Sun's trajectory, December 21, 2025, winter solstice, 1st Enoch, month 9, total sunlight time, 8 hours and 0 minutes. Sun's trajectory, January 20, 2026, 1st Enoch, month 10, total sunlight time, 9 hours and 20 minutes. Sun's trajectory February 19, 2026. First Enoch, month 11. Total sunlight time 10 hours and 40 minutes. Sun's trajectory March 20, 2026. Spring equinox. First Enoch, month 12. Total sunlight time 12 hours and 0 minutes. A sequence of the sun's trajectory from month 1 to month 12 will be shown next. At solar high noon, 180 degrees azimuth, the sun's latitude degree location south of plus 50 degrees latitude equals 90 degrees minus the sun's altitude angle. For instance, on March 20, 2025, spring equinox, first Enoch month 12 at solar high noon, 180 degrees azimuth, the sun's altitude angle is 40 degrees. The sun's latitude degree location south of plus 50 degrees is 90 degrees minus 40 degrees, which equals 50 degrees of latitude. The sun is physically located above the equator and the sun's last day in gate 3. The sun's physical latitude location from the equator for the other dates or months can be determined with the same calculation process. April 20, first Enoch month 1, the sun's latitude location is 11.7 degrees north of the equator and the sun's last day in gate 4. May 20, first Enoch month 2, the sun's latitude location is 20.1 degrees north of the equator and the sun's last day is gate 5. June 21, summer solstice, first Enoch month 3, the sun's latitude location is 23.4 degrees north of the equator and the sun's last day in gate 6. Latitude 23.4 north of the equator is the Tropic of Cancer. July 21, first Enoch month 4, the sun's latitude location is 20.4 degrees north of the equator and the sun's last day in gate 6. August 21, first Enoch month 5, the sun's latitude location is 12 degrees north of the equator and the sun's last day is in gate 5. September 22, fall equinox, first Enoch month 6, the sun's latitude location is 0.2 degrees north of the equator and the sun's last day in gate 4. October 22, first Enoch month 7, the sun's latitude location is 11 degrees south of the equator and the sun's last day in gate 3. November 21, first Enoch month 8, the sun's latitude location is 20 degrees south of the equator and the sun's last day in gate 2. December 21, winter solstice, first Enoch month 9, the sun's latitude location is 23.4 degrees south of the equator and the sun's last day in gate 1. Latitude 23.4 south of the equator is the Tropic of Capricorn. January 20, 2026, first Enoch month 10, the sun's latitude location is 20 degrees south of the equator and the sun's last day in gate 1. February 19, 2026, first Enoch month 11, the sun's latitude location is 11.2 degrees south of the equator and the sun's last day in gate 2. March 20, 2026, spring equinox, first Enoch month 12, the sun's latitude location is 0.1 degrees south of the equator and the sun's last day in gate 3. When looking at the color coding of the sun's location north and south of the equator, we observe mirroring occurring right at the equator line. Yua's intentional intelligent design of the sun is evident in this presentation, proving the movement and sunlight coverage of the sun stated in 1 Enoch chapter 72 during a year is verified by actual hours of sunlight observed from the United States navigational data. In conclusion, 1 Enoch chapter 72 sunlight coverage is verified by observed navigational data. On day 4 of creation, Almighty Yahuwah brought forth the sun. The sun obeys Yahuwah's laws and commandments every year as stated in 1 Enoch chapter 72. Praise Yah.